think I'm up on live on everything. Maybe everything, maybe not everything. 1 second. Okay. YouTube says I'm live. Discord says I'm live. Twitch says I'm live. Everything says I'm live. So I'm live. I'll assume I'm live. So today is going to be something fun. Something fun and out of the ordinary, out of the usual, off the usual beaten path of things, as we say. Before I entirely get into that, though, I do want to mention, to remind everyone, hopefully, let's see if where am I here? I thought I had screen working on here, and strange how that doesn't work. Display capture, come on. Nope. Somewhere right about here in terms of Monday, Thursday. And the list here says serialization and testing. But something much more exciting came up. So the important part of the schedule is that officially the Project 3, the Shoot 'em Up project, is due somewhere between now and Monday. So I've decided to make that Sunday night. So Sunday at midnight so that I can start grading on Monday. That means I will not have the grades for Monday. They might be running a little bit behind. But please do try to get things in late Monday. Remember, there is a clock that starts ticking. If you do hand things in late. One thing I am officially changing as of right now, if anyone has this issue, I don't expect there to be too much of an issue with this, but after normally it's like a 10% or grade that gets knocked down for each day. It's late. You can, the last one is actually, I'm going to say, instead of a day, it's a week. So if you return your project in within 2 weeks, you can get 50%. So all is not lost. You can still get, I don't like you get 0, so don't bother to turn in anything. So you should always feel like turning in something is better than turning in nothing. So that it will, especially if you've got like just that one project that hits you real hard. So anyway, I expect everyone to really have their stuff in on Sunday. Ask me questions, see what people are typing. So hopefully I can see that now. All right. I'm getting whiplash looking at multiple monitors here. This is just... But you may choose to, of course, use it now that Unity has decided to make something that is available to everyone. And that's letting the cat out of the bag there. Let's see. Let's get back to this screen. And you probably, hopefully, recognize this, something like this. This isn't the completed shoot 'em up game, or not. Excuse me, not at all the shoot 'em up game, the ApplePicker game, but. Let's play it. Let's hit play. Let's see what happens. You may not hear audio depending on what platform you are streaming on. There's a little bit of audio in here. And hopefully this looks reasonably familiar. That we see we have our villain hidden disguised as a tree who is trying to hurl apples at us here. And we have to catch them in our Lego basket box here. So it's a little bit, the playback's a little bit chunky because of everything that's kind of streaming and going on all on the same screen. But the general idea is kind of there. I've left out a bunch. It's not complete. It just started this off. And the cool thing now is how you of course are expecting there to be some code behind that, I'd imagine, our traditions. So this is the Bolt visual scripting language that is now available for free. The company Ludic was bought by, or not, excuse me, the company wasn't bought, but the tool was actually bought from Ludic, and now Unity owns it, and Unity is providing it for free. If you go to the asset store, you can find it for free. So let's see. For example, I heard about it yesterday through the grapevine, but I think there's some emails that went out today if you are subscribed to everything. And this is definitely worth getting and checking out. Why? Well, one of the things, especially if you haven't taken Game Dev 1 yet, and you haven't done anything with Unreal yet, a big piece of the programming style in Unreal, one of the choices you have is, do you want to use C++ or do you want to use Unreal's blueprint system? And you'll using this sort of visual programming inside of Unity. And if you use it now and you get used to it now in Unity, you'll have an easier time, I think, picking it up in Unreal later. So that's really cool. It's especially cool for people who do not like sort of or a little bit turned off by the traditional text-based programming. Now, that's not to say it's, well, they anything you could do in a traditional script, you can do in these graphs. Okay, I'm not going to step through the actual installation of Bolt. That's something you can do on your own, but it is worth doing that. Now, let me scroll down to see. Okay, I want to kind of keep an eye out for any questions, so you can jump right in at any point. So the idea is that just like a class, you have, instead of having a, which is sort of it's not exactly a flow chart, but it's a process flow diagram with elements in it that respond to different sort of bits of functionality. Okay. And there will be things that kind of trigger, and you'll see that process control and information will flow through these graphs and cause things to happen in your game. So, for example, this flow graph is actually on the basket, right? So the basket, we had a couple of things, and this is a greatly simplified version of it. I put this together rather quickly. I just got Bolt, the free version myself yesterday. I've done a lot of visual programming in other languages, things like Max for Live, and certainly Unreal Blueprints, and a couple other different things over the years. And it's a lot of fun. It's really great for sort of quick prototyping things. And some of these you'll see, you know how straightforward certain things are. So let's see, is this the, let's look at, we'll go over here, and I'm going to select the Lego tree for starters. All right, so the tree is normally our enemy, right? It's the guy that moves back and forth on the screen dropping apples, right? You remember him dropping apples. So up here, you see a lot of familiar things, or regular components. This is something that you do that is there in addition to your scripts, not instead of, right? So this is something that you get as a additional option. Now, this next one here, this is the behavior, the basic behavior of our tree that goes across the screen, right? So I implemented not everything, like I said, but enough so that it is reminiscent of the game. So let me see if I can, let's kind of squish this a little bit. I think you may remember that in most of your Unity scripts, you by default have a start and an update function. Okay, so when you create a component, a flow graph component on a, excuse me, I've got another something. And what this is a, let's see, if we add a component, you'll see we can add that help support it as well as you get into some of the more advanced features. So the ones that we are mostly interested in right now, we're going to take a look at flow to our typical scripts. I'm going to ask that everyone just pause and stand by for just 1 second, because there's something I have to take care of. I will be right back. I'm going to leave this sort of running in real time because I don't think I can pause quite everything. So hold on just 1 second. Thank you. Okay, thank you for that bit of patience. We're having a pandemic moment here. Nothing to worry about. So in our basic flow graph here, you can see if I create a basic flow graph, just like creating a basic script, I'm presented with this kind of start and update. But instead of being functions, I have these events which can then trigger some set of functions or some set of chain of events, basically. And a chain of events is very analogous to a typical method or function call, okay? Now, also in here, you'll see some other things. There is a graph inspector and a variable tab here. And that lets you see kind of like if you click on something in here, it will tell you about the events. And then you can create things like variables that you can refer to, just like you would create your public, private, and so on and so on. All those variables within the graph so that you can kind of get at them. All right. So we now have, let's see, I'll skip this one for the moment, and we'll disable that flow machine, and we'll look at this flow machine. And I'm not quite sure why it wasn't being called that, but let's go back there, edit the graph. And where are we? We'll click on that one. Edit that graph. There we go. Okay, I'm still learning my way around that interface as well. So, like you said, we have our start event and our update event. And you can see in here, like basically all of these boxes, everything that happens from here on and is connected by these green arrows is sort of part of this set of functionality. So this is, you can think of this as being all the stuff that's in our update event or update method. And up here is everything that happens in our start method or start function, right? So we can kind of step through some of this as we go. And so let's take a look. So we have an update event, and what happens normally, we're going to create things as we need them, and they will be kind of modifying different bits and pieces here. So imagine we have an event that happens, and what are we doing in our update event for the tree? Normally we're moving the tree, right? It's moving left and right. How do we do that? We normally use a translate function, right? So this box here, and you'll see if I right click, I'll get a little context menu saying add unit and so on. Now adding units, these boxes are all units, and I can refer to the object that this is on. You'll see the Lego tree is the game, and I can see the game object, the transform, and the other components. So I can even look at other pieces and parts and things of that. Or I can even do things like say, let me look at the transform, and let's get the translate function. Particular flavor existed, which would have been even easier for me to use here, because in here, I wind up using a vector 3 and multiplying that by my direction, when I could have just translated according to the X if I had known about this particular box. But anyway, I guess it's not that much stuff really redundant in there. Well, let's keep that to the side. Maybe we'll use that instead. We'll rewire that. So flow goes this way, follows the green arrows. So as it hits a box, it will do everything in the box, and it will try to make sure that all of these inputs are satisfied. If something doesn't have an input, it's just going to use, sometimes it uses a default value. So here, the transform translate is referring to itself, meaning the object that we're on, and it wants to find, okay, what are the values that are going to be passed to that translation? Okay, and it kind of works backwards from here. When you see these dots as opposed to these green arrows, you got to imagine them as sort of vacuuming in, drawing in the information they need here, kind of working their way. So we see it needs this. So, okay, what is it doing? We can work our way backwards. To get this translation, it is multiplying two things. And what are those two things? Well, we'll work all the way back here. We can say, on delta time, so we're getting time delta time here. So we know the slice of time, and we are multiplying a variable called direction to that, right? So direction is going to be the direction, and delta time is the amount of time, right? So we are now saying, all right, if direction is 1, we're moving in a positive direction. If direction is -1, we're moving in a negative direction. So then we multiply the amount of time that's passed. So we know how much to move, right? So that gives us this new value b, right? The multiplication, the result of these two. And then what we're also doing is we're doing a scale by a speed, or the offset per step here, per step, right? Now, this offset and this direction here, these two named variables, these are over in here. You can see I've set them up ahead of time. They are graph variables. They're only available, excuse me, as, okay, move 5 in the x direction and 0 in the y direction, right? So it is a vector, and direction is just an integer, and by default it's 1. So it's either be 1 or -1. Now, if I wanted to add a new variable, I could say, oh, okay, let's do this. Let's have another thing that's called speed, which is a little odd, but anyway, we'll call it speed. And speed direction, or my offset now, to be just 1. And so what I want to do is I want to multiply this times this speed. So I would do that by adding a unit, and I can just type in multiply, and it'll find that for me. Or I can go look through the math libraries and so on. One side is that. Now I have to get that other variable to use there. Now I don't think, can I do this? What do you know? I can. I can drag it right from there into here. Now I can say, all right, give me that variable, right? So now I'm going to take speed, which is my 5, multiply it by my offset vector, which is this 1 in the x direction. And then that becomes one of the multipliers of the other side, which is basically that is our direction and our time there, right? So then that flows through. I wind up with this new vector, this translation vector for every step of update, right? So that would move my character right along. Now, what I'll do, just to make life interesting, I'm going to say, all right, temporarily, I'm going to disconnect this. And what I want to do is I want to just go ahead and update it. All right. That would be enough. All right. So let's see. We'll save that. And it will auto-save as well. You don't have to explicitly save. Let's put it down here, and let's watch what's going to happen. And it continues and moves right off the screen. So he's continuously increasing. He's never changed direction. And we can watch the flow. You see, okay, here's the update event happening. Here's drawing all of these things through here, and then it ends at translate. Now, you can also see it doing its instantiation of our apples that we're dropping up here. But the one thing it's not doing is not moving the character back on the screen ever. So for now, let's do this. And you'll see he's going to come back onto the screen now, eventually. Yes, this is all very dynamic. We can change things as we're on the fly as we're going here. Back to 5. It's all very live, which is nice. So we're back on the screen, and he's doing the right thing again. All right. So this second bit of code here, this down here, is the part that decides how does it change direction. I mean, how does it change direction when it hits the side of the screen? All right. Right. Our program flow goes here and then dead ends. And if I hit play, you saw it dead end there, right? So that again, just to point out. Okay, it's dead ending there. Nothing is happening. I can then extend it and decide, okay, it should continue on. And then suddenly you see it goes here, then here, then here, and so on. All right. So let's kind of walk through this and see what it's doing. All right. So it's saying, okay, execute this next. Okay. And this is a true-false branch. So it has to go in one of two directions, this way or this way. And where does that come from? Well, this is comparing two numbers. And what it's comparing is, we'll kind of move our way backwards. You'll see, vector x, okay, it's a vector 3. It's getting the x value of the transform position, right? So it's getting the position of this becomes true, okay? At the same time, it also compares, roughly the same time, sort of the same time, it's going to compare to see, is it less than -4? So this should look familiar to you from the ApplePicker. So the logic was, okay, if the x position is greater than 4, we know we want to change the direction. If it's less than 4, we want to change direction into the positive direction. All right. So we see this sort of cascading set of branches here. And this is basically an if, else, if sort of, right? So we have if this is true, it's going to come through here and do this select. What the select means, okay, now if true, this would happen, and it would say, all right, grab the number that corresponds to the A input. So you see this flow coming in as A, and there's also an input for a value. So it's if A, then return -1. If B, return 1, okay? These are literals. Okay, you can add literals by just saying an int literal. I think you can also just say int, which is the system. Let's see, is that int literal? Okay. And that could be anything. We could say, oh, is it? So, okay, if this, then we pass -1. Otherwise, we come down and we check this other condition. And if that's true, we set it to 1. If that's not true, we don't do anything. We fall through. That's why it's an if, else, if. And then there's nothing that occurs after that, right? So if either of these occur, program flow will continue. And what it'll do is it will set the value of direction to either 1 or -1, depending on what happened, right? So we can set that value, right? And it just continues through. Now, you might say to yourself, well, what happens after here? It just stops, right? Sort of, kind of. Well, that's okay. It's okay that it stops there because direction, this is setting direction. Now, in other parts of our code that sort of asynchronous, and it's like a first come, first served sort of thing. It's like, okay, if this was set, next time we do a get, we get the value that was set. Right. So that's why the flow is a little bit funky, but it certainly does the job. So this is the visual version of our code that we had to move that. And you'll see every so often it hits the edge and it knows to do that set. Okay. Now, in the other part, let's take a quick look up here. We're not using invoke. We're not using a coroutine. We're using something that's a little bit different here in the graph, but accomplishing the same thing. Basically, one of the objects that we're provided with is this thing called a timer. And this is something that I don't know if there's a direct correlation in scripting, but there are some additional things that we can use here. So this is a timer, this box here. So let's look what happens in the start routine here, right? So in start, function comes in, and one of the first things we do is we set gravity to down, right? This is because our other stuff in our project here might have set it to something differently. So just like other games, other scenes, we're going to do a little bit of setup here. So the first time when this starts, it sets gravity pointing down, just to convenience. And then our start routine starts this timer, right? It presses this, or program flow goes through here and starts the timer. And when that timer runs out, this happens, completed happens, and flow goes through there. All right, let's move this up so maybe we get some things that aren't quite as crossing one another. All right, so on a completion of this timer, then we have an object.instantiate. Right, this is our familiar instantiate. Remember, it takes a prefab, it takes a position, it takes a rotation, and that will instantiate an object wherever we tell it to. Now, for position, well, guess what? For position, we're doing a get on the transform.position of the object that we're on. The game object that we're on is our tree, right? So we use the position of the tree as the position of this new prefab. We have quaternion.identity as the rotation. So we instantiate a new object here. And then, last but not least, we do something to be sort of recursive, right? What we do is we say, okay, when this completes, the program flow then goes over here and rolls a die, right? It does random range, and it gets a number between 1 and 3 and passes that in as the new duration of our clock, our timer, and it also starts the clock, right? So it sets a new timer duration and restarts it. So so this bit of code took the place of our, I think we use the invoke or invoke at a certain time. So we did that with this instead. So we use this timer to trigger this program flow. So every 1 to 3 seconds, we trigger this instantiation using the position of our tree and just a quaternion identity, and then schedule the next one. Very, very, very similar to our other code. All right. Now, so that's everything that's going on inside the graph for our tree. Let's take a, this is a simplified version, of course, but we have a flow machine here on the Lego chest. And if we edit that graph, we can see there's basically 2 things going on, okay? We have a start event that's not doing anything, but we do have an update event, right? So similar to our other code of the mouse, which is in screen coordinates, convert that to world coordinates, and then move the X position of the basket, or the Lego chest in this case, to match where that mouse is left and right. So up here, let's see. So it's a challenge. Whoops! It's always a challenge to try to fit things on the screen. This is one of the reasons that having multiple screens comes in really handy. I really use this moving left and right, just like we expect, and it doesn't move up and down. It just moves left and right. You'll notice it also, even if an apple collides with it, it does get destroyed like it should. All right. So let's see what's happening here. You'll see. Let's see. I'm going to try. All right. So you'll see if an apple collides with me, just like in our normal script, the on collision enter 2D event happens, and then some code gets triggered. And what does that code do? Well, that code, the event happens, it will trigger this, which is a object destroy. So it's going to destroy whatever object is passed to this. And we just want to tell it, okay, let's look at it. Would get the game object attached, associated with that collider, and destroy that after a delay of 0.1 seconds, right? Very, very similar to, let's see, I'm going to try to find in our other, where was it? Apple tree scripts. Player behavior. Yeah. this was fancier than that. It had 3 baskets, but you'll see in here, it's the same sort of thing. It has in update, get the mouse position, convert it to a world position, and then assign that. We are potentially adding baskets. No, that's not what we wanted to do here. Oh, that's if we, okay. In our other game, I think what we did is it's in the Apple behavior. All right, is it in the Apple behavior? That, yeah. On collision enter 2D. So it sort of does the opposite. It says, okay, on collision enter 2D, if you are the Apple, you collide and you destroy the current game object, not the game object that you collided with. So it took responsibility for it in there. So like anything else, you know, it's 6 of 1 half. So we have our update event, which says, okay, first thing to do, want to get we want to convert something, draw this vector, pull this vector in from mouse position. This is pulled, right? This isn't an event. We pull this in. And we also want to make sure which camera are we converting through. In this case, we only have 1 camera, so we're going to use the main camera. So we say, okay, this is like saying camera.main, right? So this is what converts the camera's position to a new vector, a world point, right? It says, okay, now do this next. So we're going to create a vector, right? A new vector that uses the X position of the camera and the Y position of whatever it was itself, right? It's not moving the Y position. It's not changing that. We're only changing the X position here, right? So this is transform position get. So it's like saying transform.position y.y. Use that value. Combines those two things, the new X value with 0, and then it does a set of that position to the transform.position of the object, right? It's just like in our other code, right? Nope, let's find the one. Player script here. I think this one. Okay. It's a little bit different. But anyway, we grab the mouse position. We convert it to a word. Fun. And then we set the position of the object to this. Now, we did this a little bit. So initially, we saved out this position through this temporary variable, but it's the same. It's kind of the same thing. In the end, when we created this new vector, we could have said, okay, transform or ppos.x equals this, ppos.y equals the y value from the current object, and then saved it back out again. But it's the same and how you can use it. So it's a matter of preference. It's a matter of, you know, kind of what you're aiming to do. Some people find it easier to think sort of visually, and it is kind of cool to be able to just say, okay, what type of object do I need? Let's see. I want to modify the sprite renderer color here according to something, right? On collision enter 2D, what I'll do, so on a collision, what would I do? Well, it's going to destroy it on collision, so that's no good. I don't want that to happen. I can't think of anything offhand to rehearse that one out. But that's you get the idea, right? We can quickly add things in, change functionality, kind of prototype things. And for the sake of debugging, it's really interesting, really cool to be able to see, you know, how right now there is no collision. Okay, collision occurred. So the debugging is very, very interesting here. Now, this is actually running much faster than these little bubbles would indicate, right? It's running at potentially 100 times a second on my computer, but it's going to kind of scale it down just a little bit. So there's a little bit of conversion going on. But this is happening in real time, where, you know, we're seeing these these collisions. Actually, they'll be more closer to instantaneous here, but you get the idea. So for today, as far as assignments go, everyone has their projects to finish up. I will be looking for those. Then if you want to try things out, and I would encourage you to go ahead and try, perhaps in the next project, to start doing some things in Bolt. It'll be interesting. You can also start thinking about, also for fun, where I kind of left off. What new things did I add to my game here? Well, the one good thing now that I can do is we can come here. I'm expecting everyone to have this working so that we can go to the shoot 'em up game in your game. Oh, you know, I bet it's not going to work because, oh no, it did. Okay, thank goodness, didn't make a liar out of me. Squirrel's on the opposite side of this wall here, which is kind of bizarre. Okay, so the squirrels, the idea of the game now is to attract the squirrels. Whoops, I just teleported him somewhere. I hope he's okay. Drag. Or maybe, oh no, he got gathered because he appeared down in here. So that's cool. All right, so we want to gather the squirrels. We're going to get them to take notice of us. Right. Drag them over here and kind of hurl them into the squirrel hole. So you see 3 squirrels gathered. And this is a town folk who needs to be paid off or they will kind of come and shoot you. Basically, there's a bounty on your head. It's kind of the way they get it. That's the thing. So you'll notice if he sees me, he will start shooting arrows. And one of the cool things is now arrows will stick into things. And I have to pay him off somehow. So that's the idea is to pay off the bounty hunters. That's my story, and I'm sticking to it. So yeah, unfortunately, my catastrophic error did delete 2 interiors that I was working on at the time. But you see, this one still works. I can come over to here, come to this little faraway town thing. I come back out the squirrel hole. And we can continue on around. We added the danger zone. It's not working. And that's the idea of the game. So the game is, you see, okay, I paid off. There's no more. I paid off all the town folk. It says done, right? There still must be more squirrels, though. And in the end, it's going to be a combination. It is a random number of squirrels are generated. A random number of town folk are generated. So it's tough really figuring out a high score. It's more just a open-ended fun game. I think the score will probably be a combination. Maybe we'll just say, well, how quickly did you do it? So I'll print out a timer to say, okay, at this time, you completed both tasks. We have sort of 2 simultaneous tasks. I could certainly add more tasks to say, okay, how many chests did I collect? Well, and let's see. The other cool thing is if we do wander, we see the little scarecrow here. We can bump into him and find ourselves in the game. And let's see. Let's lose the game. Whoops, I didn't mean to do that. Here we go. Let's see. There we go. If I press space, I wind up here. I can go back into my shoot 'em up game. I've been working on some, subtle things as well. It's the rate that he moves at. There's some things, smart things about the way the squirrels are. You can push them into the gathering holes. There's a whole bunch of squirrels got gathered there. Yeah, I'm very happy with how it's turning out. Oh, okay, squirrel. All right. Hello, I'm a squirrel. Come on. Let's see if this would be enough. It's funny. You want to avoid the rune stones while a squirrel is following you, because if you, this is kind of watch this, ready? Oh, suddenly becomes stunned and he can't do anything. But I think, can we do this? Yeah, we can shove the squirrel. Oops. There we go. We gathered all the squirrels. We paid off the town folk. We're done. So that's my shoot 'em up game. And a little wrap up of our menu system here. We still don't have the platformer. That's what's next. And the shoot 'em up. Oh, I stopped the game. The shoot 'em up should have some way to go from the shoot 'em up to the platformer. So that'd be cool as well. All right, I'm going to stop there. I don't think there's any questions. If you do have any questions, oh, does the platformer have to be 2D? Someone had asked. Okay, no, it certainly doesn't. You'll find, I mean, a 3D platformer is certainly more ambitious, especially one of the things we're going to want to do is work with obstacles and joints and physics joints and materials and so on. It's going to be a little bit more complicated to do that with an active environment, right? We want to do more active environment stuff in the platform game. But if you want to try that, or if you want to do things that make the environment look 2D, like 2.5D, we're going to talk about that a little bit as well. I actually do have a little bit of presentation about incorporating 3D elements into a 2D game. We'll talk about that probably next week. All right. And barreling right along. Yeah. Public service announcement. If you are thinking about taking computer graphics next semester, please do sign up soon. I think we still are watching this after the fact. All right, I'm going to stop all the streams and I will keep monitoring the